This is for 8th grade, Module 4, Lesson 27, using substitution. When we have a system of equations, we can find the solution by graphing. Only if it ends up on a perfect whole number point is it easy to find that solution. There are other times we need to use the other methods or algebraic methods to solve the system, meaning find out what x and y has to be that both of them share in common that will make them true. Substitution is one of those methods. The way substitution works is if I know 3x plus 5 is equal to y and 8x plus 3 equals y, I can set these two equal to each other because they are equal to the same thing. So that is what I will do. I will do 3x plus 5 equals 8x plus 3. In doing so, I have eliminated one of my variables, so I can solve for x in this case. In doing that, I can subtract 3x from both sides. I'm left with 5 equals 5x plus 3. I can subtract 3 from both sides. I'm left with 5x equals 2. I can divide both sides by 5 to make x equal 2/5. When I find x, now I can plug that up in either one of the equations up above and solve for y. So that is what I will do. I will choose the first one, y equals 3 times 2/5, because again that is what my x equals using this equation, plus 5. Now it's a matter of just simplifying, doing order of operations where I will do top times top, bottom times bottom, equals 6/5 plus 5. And then order of operations tells me to do the addition. Y equals 6 1/5. So my solution to my equation would be the point of x being 2/5, y being 6 1/5. Now I tell the kids that it does not matter whether this is in whole mixed number form or improper fraction. It is whatever is easy for them to use, because we can always convert it if need be, if we needed to graph or manipulate it back up into the equations. Now there is a second form of substitution. It looks like if I'm looking at an equation similar to this, I don't have it where both equations are equal to the y or both equations are equal to the x. But I can put this value of 11x minus 1 into the variable y. So I would do 4 times 11x minus 1 because I'm substituting that entire part of the equation into where y would be. So therefore this 4 will be distributed over both terms to make it equal. Equals the 26x plus 4. Again, just finishing out this top equation. Now again, I have, by doing so, by substituting this value in for y, I have got myself down to just one variable, and now I can just solve for x. I will use the distributive property to simplify the left side, so I will end up with 44x minus 4, and then I'm just going to write down what I'm left on the right side. Now I need to get my x's on one side, my numbers on the other, so I will subtract 26x from both sides. I'm left with 18x minus 4 equals 4. I add 4 to both sides to get the number version off. I'm left with 18x equals 8. I divide both sides by 18. I'm left with x equals 8 over 18. which in lowest terms, if I want to make my numbers easier to work with, 4/9. Now that I have my x, I can go back to either equation, put my x in for that, and solve for y. I'm going to choose the second one. Again, just easier numbers. It does not matter which one you put it into. So I will end up with y equals, I've got 11 times my x minus 1. Order of operations tells me to do the multiplication first. So I'm left with 44/9 minus 1. 44/9 minus 1 does end up at 35/9. And again, I can leave it as improper fraction, or I can change it to mixed number, whichever is easiest for me to work with. But in this situation, the system to this solution would be the point of x being 4/9, y being 35/9. That would be the point that both these lines intersect at, that they have in common.